Hello everyone, myself Jay Vashit. I am from CSCB. Today my topic is on the application of Kirchhoff's law to communication nets. What is Kirchhoff's law? Kirchhoff's law first law applies to currents in a junction in a circuit. It states that at a junction in a electrical circuit, the sum of currents flowing into the junction is equal to the sum of currents flowing out to the junction. There are two types of Kirchhoff's laws. Number one, Kirchhoff's current law, also known as KCL. Number two, Kirchhoff's voltage law, also known as KVL. Uh, what do you mean by Kirchhoff's current law, KCL? The algebraic sum of the currents entering any node in a circuit equals zero, an expression of the conservation of charge. This means when when a current is coming into the circuit and leaves equal to zero. Kirchhoff's second one is Kirchhoff's voltage law, KVL. The algebraic sum of the voltage around any loop in a circuit equals zero. This is also known as conservation of energy. Example: power absorbed by a resistor is equal to P is equal to VI. Lumping element circuit modeling. In circuit analysis, important characteristics are grounded together in lumps, where separate circuit elements connected by perfect conductors named as wires. An electrical system can be modeled by an electric circuit combination of paths each containing one or more circuit elements. If a dimension of a circuit are small compared with the wavelength of an electromagnetic waves in the vicinity, that is wavelength lambda is equal to c by f. Physical dimensions of a system where c is equal to velocity of em waves and em electromagnetic waves, and f is equal to frequency of wave. For example, at 60 hertz the power line frequency in the us is equal to lambda is equal to 3 into 10 to the power of 8 meters per second by 60. Construction of a circuit model. The electrical behavior of each physical component is of primary interest. We need to account for undesired as well as desired electrical effects. Simplifying assumptions should be made wherever reasonable. Using Kirchhoff's current law, that is also known as KCL, consider a node containing several branches like I1, I2, I3, I4. In that, I1 and I2 are coming into the circle, and I3 and I4 are moving away from the center. Use difference directions. So, when the current are entering or leaving the node with no concern about actual current directions is called Kirchhoff's current law. Formula. What is the formula of Kirchhoff's current law? Sum of currents entering node is equal to sum of currents leaving node. Okay. So second formula, algebraic sum of currents entering node is equal to 0, where such as currents leaving are included with a minus sign. Formula 3, algebraic sum of currents leaving node is equal to 0. Currents entering are included with a minus sign. Major implication of KCL. KCL tells us that all the elements in a single branch carry the same current. We say these elements are connected in series. This is also known as series connection, where the series is connected by end on end. This is also known as end on end connection. Current entering node is equal to current leaving node, that is I1 is equal to I2. KCL example like minus 10 mu ampere on minus 5 ampere is coming into the center, and minus 15 ampere is leaving the circuit, where which shows minus 10 plus minus 5 is equal to 15, minus 15, sorry. So leaving is also minus 15, that is which satisfies the equation current entering node is equal to current leaving node. Now we'll talk about generalization of KCL. Sum of currents entering or leaving a closed surface is zero. Is zero. Circuit branches can be inside this surface. The surface can enclose more than one node. This could be a big chunk of circuit. Example, black box. Generalized KCL examples. When a loop, no, using Kirchhoff's voltage law, KVL. Consider a branch which forms part of a loop, like a loop and voltage drop and voltage raise. Use reference polarities to determine whether a voltage is dropped or gained with no concern about actual voltage priorities. Formulation of KVL, like Kirchhoff's voltage law, also known as conservation of energy, sorry. Formula 1. Sum of voltage drop around the loop around the loop is equal to sum of voltage rises around the loop. Formula 2. When there is a rise in included with the minus sign, algebraic sum of voltage drops around the loop is equal to 0. So, formula 3. This is when voltage drops are included with the minus sign. Algebraic sum of voltage rises around the loop is equal to 0. Just a small handy trick. Look at the first sign of the encounter on each element when tracing the loop. Okay, the major implementation of KVL. KVL tells us about that any set of elements that are connected in both ends carry the same voltage. We also say these elements are connected in parallel, also known as parallel connection, like side on side, parallelly kept. Applying KVL on clockwise direction, starting the loop. For this loop, we have sign conventions also. An underlying assumption of KVL: no time varying magnetic flux through the loop, otherwise, there would be an include voltage, also known as Faraday's law. Antennas are designed to pick up electromagnetic waves, and regular circuits often do so undescribably. How do you deal with antennas? Include a voltage source or as a circuit representation of the include voltage or noise. Resistors are in series. Consider a circuit with multiple resistors connected in series. So we have to find a equivalent resistance. KCL that tells us about that same current flows through every resistor. Kirchhoff first law is also known as the junction law, and Kirchhoff second law is also known as the loop rule or loop law. How to use Kirchhoff's rules? Number one, label all currents. Number two, write down the junction equation. I in is equal to I out. Choose loop and direction. Like choose any direction. You will need to one less loop than unknown currents. And last, write down voltage changes. Like for batteries, voltage change positive when summing from negative to positive, and for resistors voltage change is negative when summing in the direction and the current, also known as sign conventions, which are used to solve problems. Kirchhoff's junction law. The first two can be calculated using VIR. Like VIR is a basic formula which we need to be reminded every time when we use Kirchhoff's law. Kirchhoff's law states also that KCL is also known as Kirchhoff's first law in junction. The principle of the law is to conserve the electric charge. The law states that the amount of current flowing into the node is equal to the current flowing out of the node. Kirchhoff's law are two equalities that deal with the current and the potential difference, and in the lumped element model of an electrical circuit. They were first described in 1845 by German physicist Gustav Kirchhoff, which is also known as Kirchhoff's current law. This generalized the work of George Ohm and preceded the work of James Clerk Maxwell. According to Ohm's law, Kirchhoff's voltage law, and Kirchhoff's current law, are essential in analyzing linear circuitry. Kirchhoff's law deals with the voltage and current in the circuit. Ohm's law relates voltage and current and resistance to one another. These three laws apply to resistive currents, where the only elements are voltage and are circuit sources and resistors. Using the three laws, any resistance of circuit current through or voltage across a resistor can be found if any two are already known. The purpose of this report is to provide verification of these laws. Section 2 outlines and 3 laws gives simple examples of conventions. Section 3 analysis the circuit based solely of the schematic and generates the three equation needed for the further analysis. The equation holds true only if the passive sign convention is satisfied. In the case of KVL, the passive sign convention takes that when a positive node is encountered while functioning a loop, then voltage across the element is positive. If a negative node is encountered, the corresponding element voltage is negative. In order to simplify the KVL equations, the polarities should be assigned to satisfy the passive sign convention whenever possible. Now, in the case of KCL, the passive sign convention deals with the direction of the currents with respect to the node. Currents entering the node must have opposite signs are those existing in the node. The passive sign convention with respect to KVL can also be applied to KCL. On many schematic and polarities of resistors are already assigned to the direction of the current should be assigned such that the current is entering the positive terminal. This will simplify after calculations. The currents, voltage, and polarities were labeled as given. The current directions and voltage polarities have all been assigned. Such the passive sign convention will be satisfied where possible. The four resistors were chosen at random. The resistance was the measured with a multimeter. The nominal and measured resistance values. The P-size simulation does verify KCL in order to use KVL equations. Ohm's law had to be applied to the resistor and the current flowing through them. This gave the voltage across each resistor. These voltages are then inserted to other. The circuit was constructed by a breadboard using four random resistors. 10 volts was measured on the CADET trainer's power supply. The applied to the current. The voltage across the current through each of the resistors was then measured and recorded. The simulation of the circuit verified KCL. P size found sum of two currents exciting the node to be equal to the current entering the node. The experimental results of the KCL test were not so close. There was less than 2% error between the measured and calculated I1s. This error is acceptable in stating the KCL is true. The simulated KVL test was not as expected. Neither both produced 0 volts. However, both the equations added up to the voltage small enough to be negligible in starting that KVL is fine valid. As the KCL tests and experimental KVL results in 9 not meet the predicted values. Both of the equations produced values within 1 volt away from 0. There was a larger discrepancy of that found, but still enough to conclude the KVL is valid. All the percent errors and calculated versus measured resistance were less than 8%. This is probably due to the error accumulation in the calculations. A major source of error applies all three cases was the measuring process. So, in the conclusion, Want to tell like Ohm's law, KVL, and KCL are three most basic techniques for the analysis of linear circuits. The purpose of the lab was to prove these three laws are valid. A circuit was provided within four known voltages and three unknown currents. This voltage was constructed by in P size and simulated. Then the circuit was built on breadboard. The voltage and current values were measured and placed into KVL and KCL equations to determine whether they turned out to be as predicted. These measured values were then used in the Ohm's law equation to find resistance. The calculated and the measured values were then compared to the expected results as the theories in section 2.0. All the differences between tested and expected values were small, therefore, all the three laws could be considered valid. The total current gets divided in parallel circuit while the voltage across the each element is the same. The current diversion rule can be understood by considering a parallel circuit, and so mainly the Kirchhoff's law was first described in 1845 by German physicist called Gustav Kirchhoff. And the last mostly mesh analysis. Let us learn about mesh analysis to planar circuits to do not contain current sources. In the mesh analysis of a circuit with n meshes, we can take the following three steps. Like number one, assign mesh currents like I1, I2, and n meshes, which is extendable, and apply KVL of each the n meshes. Use Ohm's law to express the voltages in terms of mesh currents, and lastly solve the resulting n simultaneously equations to get mesh currents. And then there comes the super mesh concept, like similar to mesh concept, but this is different, a bit different. When current source, dependent or independent, both occurs between two meshes, we apply super mesh concept to solve the circuit. We create a super mesh by excluding the current source and of any elements connected in series with the while taking KVL. For learning about Kirchhoff's law, I would suggest the most book like written by Charles K. Alexander and Matthew Siddiqui, named as Fundamental of Electric Circuits, powered by McGraw-Hill Education. So this is the end of the topic. Thank you. Thank you, everyone.